In 6 days, an object weighing 33 billion tons will pass close to Mars. NASA says it's a comet. Harvard says that's impossible. The data reveals something far more disturbing. This is 3I Atlas, the third confirmed interstellar visitor to our solar system. But here's what they're not telling you. It defies every model we have about cosmic debris. We should have found 100,000 smaller objects before discovering something this massive. Instead, we found 2 tiny visitors. Then this behemoth appeared, perfectly aligned with our planetary plane. The statistical probability? Nearly 0. But the size isn't the strangest part. James Webb's spectroscopy revealed something that makes scientists whisper in hallways: nickel without iron. Industrial-grade alloys that, according to Harvard's Dr. Avi Loeb, only exist through artificial carbonyl chemical pathways. It's as if the cosmos held its breath, then exhaled a riddle wrapped in ice and metal, racing toward Mars with the precision of clockwork. 3 questions haunt every observatory on Earth. Why is it so perfectly aligned? What kind of stellar explosion creates industrial metals? And why are our Mars spacecraft being quietly repositioned for the closest interstellar observation in human history? The answers lie buried in 4,000 telescope measurements from 227 observatories worldwide. The numbers don't lie, but they describe an impossible universe. Let's start with what we know for certain. 3I Atlas was discovered by a half-meter telescope in Chile, ironically just 10 miles from where the future Vera Rubin Observatory will revolutionize our search for these cosmic wanderers. The object's vital statistics paint an extraordinary picture. Minimum diameter, 5 kilometers. Mass, 33 billion tons. That's 3 to 5 orders of magnitude more massive than Oumuamua or Comet Borisov, our only previous interstellar visitors. Based on over 4,000 astrometric measurements, 3I Atlas shows minimal deviation from pure gravitational motion, despite actively venting gas at 150 kilograms per second. Think of it as a mountain-sized ice cube losing the weight of a small car every second, yet barely budging from its calculated path. Here's where it gets strange. Dr. Bryce Bolin from Eureka Scientific confirms the discovery sequence breaks every theoretical model. We should have detected an order of 100,000 Oumuamuas before discovering an object as big as 3I Atlas. The composition data from James Webb and the Very Large Telescope reveals an unprecedented chemical signature: 87% carbon dioxide, 9% carbon monoxide, 4% water, and trace amounts of cyanide paired with pure nickel. Dr. Avi Loeb's analysis is unequivocal. The detection of nickel without iron is only known to exist in industrially produced alloys. But here's what the data really reveals about trajectory. 3I Atlas approaches our solar system aligned within just 55 degrees of our planetary orbital plane. For a random interstellar object, this alignment has the same probability as flipping a coin and getting heads 50 times in a row. NASA's Tom Statler maintains the official position. The evidence is overwhelmingly pointing to this object being a natural body. It's a comet. Yet even he acknowledges its several interesting properties that distinguish it from typical comets. Let that sink in. We're tracking an object that shouldn't exist, following a path that defies probability, composed of materials that challenge natural formation theories, and it's heading straight for Mars. The scientific community has rallied around 3 primary explanations, each struggling to account for 3I Atlas's anomalies. Theory 1. The stellar explosion hypothesis. Some researchers propose 3I Atlas formed during a rare type of supernova that could forge unusual metal compositions. The nickel without iron signature might result from extreme stellar nucleosynthesis under conditions we've never directly observed. But here's the catch. No known stellar process creates the specific industrial-grade nickel alloys detected in the spectroscopic analysis. Dr. Loeb's team calculated the probability of natural formation for this exact composition, extremely small for it to belong to their natural comet class. Theory 2. The primordial remnant model. Perhaps 3I Atlas represents debris from our galaxy's earliest epochs, when star formation occurred under vastly different conditions. Ancient stellar populations might have produced exotic compositions through mechanisms no longer active today. And yet, this theory crumbles when we examine the trajectory statistics. Richik Fromish, Peter Veer, and Avi Loeb's collaborative analysis confirms this finding raises new questions regarding our expectations about interstellar objects that occasionally traverse our solar system. Theory 3, the statistical fluke argument. Maybe we're simply witnessing an incredibly rare but natural occurrence, the cosmic equivalent of winning the lottery while being struck by lightning. Each mainstream theory explains individual anomalies but fails to account for their simultaneous occurrence. Consider this possibility. What if 3I Atlas isn't naturally occurring cosmic debris at all? The trajectory alignment suggests something more troubling than random chance. Objects don't accidentally arrive perfectly positioned within our planetary plane. The precision implies targeting, or at minimum, some form of organized cosmic architecture we don't yet understand. Dr. Loeb poses the critical question: why would the first massive object possess this alignment? The answer might be that it's not random. Natural interstellar objects should arrive from all directions, at all angles. But 3I Atlas really approaches, like, it knows exactly where our planets orbit. What if the industrial-grade nickel signatures represent technology rather than geology? The artificial carbonyl chemical pathway Loeb identifies doesn't occur in natural stellar environments, but it's precisely the process human industry uses to create specialized alloys for extreme environment applications. Consider this chilling possibility. 3I Atlas might be our first confirmed detection of interstellar technology, disguised as a comet through eons of ice accumulation during its journey between star systems. The Mars approach takes on new significance under this interpretation. Dr. Boland supports the observation campaign. 3I Atlas is actually going to get quite close to the orbit of Mars, which could be an interesting opportunity for spacecraft at Mars to try and observe this thing. But what if Mars wasn't chosen randomly as an observation point? What if it was chosen deliberately as a destination? Multiple space agencies are quietly repositioning assets: Mars Express, the ExoMars Trace Gas Orbiter, Mars Reconnaissance Orbiter, for coordinated observations. This represents the largest interstellar object surveillance operation in human history. What if they're not just comets wandering through our neighborhood? What if they're scouts surveying our planetary system? Our journey through 3I Atlas has revealed a progression of deepening mystery. The facts established its unprecedented characteristics: impossible mass, perfect alignment, industrial composition. Theoretical explanations struggled to reconcile these simultaneous anomalies, and speculative possibilities opened doors to questions that challenge our fundamental assumptions about interstellar visitors. The Mars Flyby on October 3, 2025 represents more than scientific opportunity. It's humanity's first coordinated investigation of a truly anomalous interstellar object. Every camera, spectrometer, and detector orbiting the red planet will focus on this cosmic enigma for the few precious hours it remains within range. But 3I Atlas has already transformed something more fundamental: our certainty about the nature of objects traversing our solar system. The statistical impossibility of its discovery sequence, finding something so massive so early, suggests our models are incomplete, perhaps dangerously so. The industrial-grade materials persist as the most troubling anomaly. No natural explanation adequately accounts for nickel without iron, produced through artificial chemical pathways embedded within what otherwise behaves like a comet. The universe keeps its secrets. For now, the next mission could change everything when those Mars spacecraft capture 3I Atlas in unprecedented detail. We'll either confirm our first interstellar technology detection or discover natural processes that rewrite astrophysics textbooks. Either outcome transforms humanity's cosmic perspective forever. Subscribe to be the first to know when the data arrives. Because if we can't explain 3I Atlas, what else are we missing among the stars? In Cosmos we trust.